How many of you are familiar with Scrabble as a game? Oh, really? Okay. Here's the way Scrabble works. There are tiles, and each tile has a letter on it. And the letters start out being face down, so you can't see what they are. And they get all scrambled up. And you pick a certain number of them. Every player picks a certain number of them without knowing what they are, and collects them and puts them on a little tray so that only they can see what they are. Okay. And then the object of the game is to spell words on a grid. Okay. So if I were, for example, to say, I'm going to pick five tiles at random in order to put them here, the act of picking 5 letters for the tray and the act of spelling a word with 5 letters, those are very different in terms of how many different ways they could turn out. Which one has more? The left or the right? What do you think? More of these than of these? Okay. Well, let's think about it for a minute. If I'm going to pick 5 letters from here and spell a word with them, how many letters do I have to choose from here? I've got 10 letters up here, so let's just keep it simple. What's my choice for the first letter? How many? 10. And then for the second letter? And for the third? And for the fourth? For the fifth? Okay, so it's 10. We multiply these together. Because for every one of the 10 I could choose here, there are 9 more to choose from. For every one of that combination, there are still 8 left. So you multiply these numbers together. If I have, let's say, A, B, C, D, E, and then I say B, C, D, E, A, for the purposes of spelling a word, those are different, aren't they? Are they any different for the purposes of picking letters out of the box? They're the same, right? How many different ways can I arrange A, B, C, D, E? How many different orders are there? Anybody know? 5 times 4 times 3 times 2 times 1. Okay. That's how many different ways I could take the same 5 letters and change their orders around. That means for every 5 factorial, right? This is called 5 factorial. Factorial means you start with the number and then go down one by one until you get to 1 and multiply them together. For every 5 factorial ways that I can arrange a set of letters, for the purposes of picking it out of the box, it only counts as 1. That's an overcounting. Right? It means every 5-letter combination I have overcounted by 5 factorial. There are far more of these than there are of these. And in fact, we can say exactly what the magnitude of the difference is. So let's look over here for a minute. This is not factorial. Because factorial would be 5 times 4 times 3 times 2 times 1. But I don't want 5 times 4 times 3 times 2 times 1. I don't want them at all. So if I multiply by them and then divide by them, it's like doing nothing at all. At which point you might say, well, why would you do that? What would be the purpose of that? And the answer is so that I can say that this is 10 factorial divided by 5 factorial. What numbers would I use if I were working with just 3 letters out of the 10? Why 5 factorial? 10 factorial over 3 factorial? Like that? And that would be how many different ways I could make a word with 3 letters in it? Okay. Can you give me some sense of how you got that? Where'd the 7 come from? Well, putting it in terms of a more general way of doing it, if I were dealing with 6 numbers, I'd still start with 10 factorial on the top, right? What would I put on the bottom? How'd you get that? Okay. Can you generalize what it is you're saying so that we don't have to every time count on our fingers? Yeah.
Subtracting the number from 10.
Okay. So if I start with the total number of letters factorial, and I divide it by the total number of letters minus the number of letters I'm going to use, and I make that factorial, that's going to give me my answer every time, right? Okay. But that's going to give me my answer for when order matters, right? When it matters what order. If I'm doing something where order doesn't matter, then I have overcounted by however many number of letters I've used factorial. So I got to take this number and divide it by how many letters used. Factorial. So these factorial things are kind of useful so we don't have to write out the whole nonsense here. But then on the other hand, writing out total letters used, total letters not used, all of that gets kind of confusing. First of all, let's give some definitions here. Permutations are what happens when you choose some number of things out of a group and the order matters. When order doesn't matter, it's called a combination. Okay? And then the letters we use, N represents the total number of things that we're choosing from, and R represents the number of chosen things. So if we use those letters, and we use capital P and capital C to substitute for permutations and combinations, then I would say that I started with N things, and I picked them in a way that order matters into groups of R. Okay? That's exactly what we were just talking about a moment ago over here, right, where order mattered, and we were picking 5 things out of 10, and we decided that the total number factorial divided by the total number minus the number used factorial was actually how many you come up with. So the number of permutations here is going to be n factorial divided by n minus r factorial. And in terms of combinations, if I want to know how many things can I choose out of n, making r in each group, where order doesn't matter at all, then I have to figure out what this was, and then account for the fact that I overcounted by dividing. All right. So if you'll remember, I said the other day that probability is all about counting, and counting sometimes is more complicated than you might think. If I want the number of things that are in A union B, okay, there are two different ways this might actually play out. A and B might be two distinct groups. Right? In other words, the total number of times I got heads and the total number of times I got tails combined. There's no overlap here. When we were working before with the total of number of people who had jobs or did volunteer work, if I wanted the total number of people in this union, right? Here, when they weren't overlapping, all I had to do was take the number in A and add to it the number in B. Here, I have to do something else altogether, because the number that's in here, when I count J, I'm going to count these, and when I count V, I'm going to count these, right? Jobs and volunteers. That means I've overcounted by these many. So if they are overlapping, then I've got to count the number in A, the number in B, and then subtract the number that's in their intersection, because I've counted those twice. These things are called the counting principle, or at least this is part of it. And it's one of the ways of making sure that you can count the total number of things and the total number of favorable responses, favorable outcomes, so that you can figure out what the probability is.